Today's lesson is on the topic of ions. Our learning targets include being able to differentiate between cations and anions and being able to explain how the loss or gain of electrons will result in a positive or negative charge, also called oxidation state. So remember, atoms are electrically neutral. Therefore, the atomic number not only equals the number of positively charged protons, but it also equals the negatively charged electrons. This is only true for neutral atoms. So for instance, if you had an atom with 4 protons, then it would also have 4 electrons. The positive 4 and the negative 4 would cancel one another out, resulting in a neutral state. Let's consider what happens when an atom loses an electron. So take a moment and get your periodic table out and see if you can figure out what element is pictured below. Hopefully you noticed that based on the atomic number, you are looking at lithium. So lithium has not only 3 protons, but a neutral atom of lithium also has 3 electrons. In this picture, one of the electrons is lost. Once that electron is lost, this creates an imbalance of charge. So we still have 3 protons, but now we have 2 electrons. This imbalance of charge results in a non-neutral state. So instead of having an atom, we now have a lithium ion. So the positive 3 from the protons and the negative 2 from the electrons results in a positive 1 charge. When we write the symbol for a lithium ion, it does differ from a lithium atom. So for a lithium atom, notice there is no other number next to it. It's just simply Li, the symbol for lithium. But when you write the symbol for the lithium ion, you also include the charge. So that charge, once again, comes from the difference in the subatomic particles. The positive 3 from the protons minus the 2 electrons gets you a positive 1 charge, and that's how we designate or assign that charge to the ion. Positive ions have a special name associated with them. They're called cations. So one way I remember that the positive ion is called a cation is if you look at the spelling, you'll notice a plus sign right in the middle of the word. So that's how you can remember that the positive ion is associated with the word cation. Now let's consider what happens when an atom gains an electron. So go ahead and get your periodic table out and see if you can determine what element it is that's pictured here below. Hopefully you notice that it's fluorine. So fluorine has an atomic number of 9. That means it also has 9 protons. In addition, you can see in this picture that we also have 9 electrons, resulting in a neutral state. If this fluorine atom were to gain an electron, shown here, it would have 10 electrons total, but still have 9 protons. This again creates an imbalance of charge. So instead of having a resulting fluorine atom, we have a fluorine ion. The positive 9 and the negative 10 result in a negative 1 charge. So when you write the symbol for the atom versus the ion, they do look different. The atom has a neutral state because there is no discrepancy between the positively charged protons and negatively charged electrons. But for fluorine, the ion, there is a negative 1 charge associated with the symbol now. Negative ions also have a name. They're called anions. So I just remember that as a negative ion, anion. Let's do some practice using the periodic table to see if we can figure out what will happen to an atom's charge when it gains or loses electrons. So go ahead and see if you can find calcium on your periodic table. Hopefully you notice that the symbol for calcium is capital C with lowercase a. The atomic number for calcium is 20. So we know that calcium has 20 protons. We also know that when calcium is neutral, it has 20 electrons. But up here it says that calcium will lose 2 electrons. So instead of having 20 electrons, we now have 18 electrons. So consider the math. Positive 20 minus 18. What does that equal? Positive 2. So that will be the charge on the calcium ion. The symbol for the calcium ion then is calcium Ca with a 2+ charge. Because this is a positive ion, we will select cation as the type of particle. Let's try another example. Use your periodic table and see if you can look up the symbol for chlorine. Chlorine's symbol is capital C with a lowercase l. Using the periodic table, hopefully you were able to see that the atomic number for chlorine is 17. So that means chlorine has 17 protons. A neutral atom of chlorine also has 17 electrons. But up here it says that chlorine will gain 1 electron. So that means chlorine will, instead of having 17 electrons, it will have 18 electrons. So if you do the math, positive 17 minus 18, that'll give you a -1 charge. The symbol for the chlorine ion then will be Cl1-. You can also write this ion as Cl-. Just understand that if you see a negative sign by itself or a positive sign by itself, you should assume that there's a 1 associated with that charge. So a minus would mean -1, or just a simple plus would mean +1. So because it's a negative ion, we would circle anion as our choice. Let's try another example. Let's take a look at sulfur. Sulfur, you'll notice on the periodic table, has the symbol capital S. Its atomic number is 16. That means it has 16 protons. A neutral atom of sulfur will also have 16 electrons. But because it says that it will gain 2 electrons, we know now that it'll have 18 electrons. So positive 16 minus 18 equals -2. So the resulting ion for sulfur will be capital S 2-. This negative charge means that sulfur will form an anion after gaining electrons. Let's try a few more examples. Pause the video and see if you can do these examples on your own, and then check your answers. Okay, hopefully you were able to use your periodic table and work through these problems. If not, let's work on them together. So on your periodic table, if you look neon up, the atomic number is 10. That means neon will also have 10 protons. Now, if you recall, mass number equals the sum of the protons plus the neutrons. So here we're given the mass number and we're given the protons, or we found the protons rather. So all you have to do to find the neutrons now is subtract these two. 20 minus 10 gives you 10 neutrons. Now this is a neutral atom of neon. How do I know that? Because there's no charge associated with the symbol. So that means because we have 10 positively charged protons, this neutral atom of neon will also have 10 negatively charged electrons. Let's look at our next example. See if you can figure out what element K is on the periodic table. Hopefully you found K as potassium. Potassium's oxidation number, or sorry, its atomic number is 19. That means its proton number will also be 19. You will find the neutrons by subtracting the mass number by the protons, and that'll give you 20. So we have 20 neutrons. Now, typically for electrons, a neutral atom of potassium would have 19 electrons. But if you notice the charge on this ion, it has a +1 charge. That means we have one more proton than we do electron. So what has happened is that we have had a loss of one electron. So if we lose an electron, we now have 18 electrons. Okay, so just to make sure you know you're right, think about the math. Positive 19 minus 18. That equals positive 1. And that's our oxidation state here for potassium. Okay, let's take a look at bromine. Bromine's atomic number is 35. That means its proton number is also 35. Now this time we're given the number of neutrons. So in order to find the mass number, all we have to do is add the protons and the neutrons, and that'll give us 80. Now let's take a look at the electrons. So typically, if this were a neutral atom, we would have 35 electrons to match the number of positively charged protons. But if you notice, bromine has a charge of 1 minus. That means we have an extra electron. So instead of 35 electrons, we actually have 36 electrons. And just to check to see if we're right, 35 positives, 36 negatives, that results in a -1 charge. And sure enough, that's the charge on the bromine ion. Now let's look at calcium. Go ahead and find calcium on your periodic table. How many protons does it have? Hopefully you noticed it has 20. So we know that because we looked up the atomic number. Now to find the mass number, since we have neutrons, all we need to do is add protons plus neutrons to give us the total mass, which is 40. Typically, calcium would have 20 electrons. But because we have an oxidation state or charge of +2, that means we have more protons than we do electrons. How many more? 2 more. That's why it says +2. So since the proton number never changes, the electron number has to. So here for calcium, the +2 ion, we're going to undergo a loss of 2 electrons. Okay? So instead of 20 electrons, we're going to have 18 electrons. So think about the numbers. +20 for the protons, -18 for the electrons. That's going to result in a charge of +2. And that's what's on the calcium. Lastly, we have an element that we have to figure out. So if you recall, protons are the same as the atomic number. So we can use protons to look up the element. So in this case, protons, when we have 12 protons, that means we have an atomic number of 12 also, because those two are always identical. And if you look up 12 on your periodic table, you'll notice that magnesium has that atomic number. Okay, we're given the neutrons here, so we can just simply add the protons and neutrons to get 24 as our mass number for this particular atom. Now, is this an atom? Let's see. We've got 12 protons, and the electron number has been given to us this time. We actually have 10 electrons. So this is definitely not an atom. Let's see what the charge is going to be on this ion. 12 protons, 12 positives, 10 electrons, 10 negatives. Positive 12 minus 10. That's going to give us a positive 2 charge. So that's what we'll assign to the magnesium ion. And that's it for ions.